Let me start with a simple question. Have you ever looked at a monitoring dashboard full of alerts and wondered, how is all of this data even getting here? That's where SCOM architecture comes in. At a high level, SCOM is just a structured system that collects data, processes it, stores it, and then shows it to you in a meaningful way. Think of it like a monitoring pipeline. Servers generate data. Agents collect that data. Management servers process it. SQL stores it. And consoles display it. Everything flows in one logical direction. Now here's something important. SCOM is centralized monitoring. Instead of logging into 500 servers individually, SCOM gives you one control point. That's the foundation of the architecture. Now let's zoom into the most important component. If SCOM were a human body, the management server would be the brain. It does not directly monitor servers. Instead, it receives data from agents. Then it runs rules. It evaluates monitors. It calculates health states. And based on logic, it decides, is this healthy? Warning? Critical? That decision-making happens here. It also communicates constantly with SQL to store data and retrieve configuration information. In real enterprise environments, if the management server is overloaded, alerts get delayed. Dashboards become inconsistent. So the management server is not just a connector. It is the processing engine of the entire system. Now let's talk about where all this data actually lives. SQL Server is the memory of SCOM. Everything SCOM learns, performance metrics, alerts, availability data, gets written to SQL. There are two main types of data storage here. The operations database, which handles near real-time data, and the data warehouse, which stores long-term historical information used for reporting. Here's something I've seen many times in real projects. When dashboards are slow, people blame SCOM. But most of the time, the issue is SQL performance. If SQL is underpowered, badly configured, or overloaded, the whole monitoring platform feels slow. So SQL is not just storage. It directly impacts performance and reliability. Now let's talk about how SCOM actually collects the data. Let's make this very simple. Agent-based monitoring is like having a security guard inside the building. The agent is installed directly on the server. It collects detailed information, services, performance counters, logs, and sends it securely to the management server. This gives deep visibility. Now, agentless monitoring is different. It's more like standing outside the building and checking through cameras. You get visibility, but it's limited. In production enterprise environments, agent-based monitoring is the standard. Agentless is usually used for restricted systems, DMZ servers, or special scenarios. So while both exist, most real-world deployments rely heavily on agents. Now, once all this data is collected and processed, someone needs to see it. SCOM doesn't have just one interface. It has multiple consoles for different roles. The operations console is used daily by monitoring teams. This is where alerts and health states are visible. The web console provides browser-based access, useful for quick visibility without installing software. The authoring console is used to create custom rules and monitors. And the administration console manages infrastructure and configuration. Think of this like role separation in an organization. Operators monitor, admins manage, engineers design. This separation improves security and clarity. Now let's finish this section with something very important: architecture design. This is where experience really matters. In small labs, a single management server might work. But in enterprise, you deploy multiple management servers for redundancy. You use a dedicated SQL server, not a shared, overloaded database. You plan capacity ahead of time. You think about high availability before outages happen. And you separate roles properly for security. Here's the truth from real-world projects. Most SCOM problems are not product issues. They are architecture decisions made without long-term planning. Design it like production infrastructure, not like a side tool. Now that you understand how SCOM architecture works at a foundational level, let's move forward and see how this design scales in medium and large enterprise environments. Because architecture looks simple on paper, but in real projects, it's where success or failure begins. Let me start with a setup I've seen many times in real life. This was a mid-sized enterprise with around 600 servers. They didn't need anything fancy. They needed stability. We designed a single SCOM management group with 2 management servers, load balanced. SQL was on a dedicated server, not shared with anything else. Every server had the SCOM agent installed. And you know what? It just worked. Alerts were timely. Performance was stable. The NOC team used only the operations console, and they rarely complained. The key lesson here is simple. Most environments don't fail because they're small. They fail because they're poorly designed. Now let's talk about a large enterprise, over 5,000 servers. Initially, SCOM was blamed for being slow. Alerts were delayed. Dashboards lagged. But when we investigated, the issue wasn't SCOM at all. It was SQL Server. The operations database was overloaded. No high availability. No proper disk performance. Once we moved SQL to a cluster with always on, everything changed. Alerts became instant. Reports worked again. The biggest takeaway? In large environments, SCOM performance is actually SQL performance in disguise. Some environments don't play by normal rules. In banking and government networks, installing agents everywhere is often not allowed. Security teams are very strict. So instead of forcing agents, we used gateway servers. Production servers stayed isolated. SCOM stayed in the main network. Monitoring still worked, safely. But here's the truth. Agentless monitoring helped, but it was never as detailed as agent-based monitoring. Lesson learned? Security requirements shape architecture, not the other way around. Let me be honest. Most SCOM issues are self-inflicted. Here are mistakes I see repeatedly. Only one management server. SQL running on a weak VM. Too much agentless monitoring. No growth planning. Everything looks fine on day one. Problems start after 6 months. And then SCOM gets blamed. But the root cause? Architecture decisions made without thinking long-term. Now let me tell you what good architecture feels like. Alerts arrive on time. Dashboards load instantly. False alerts reduce drastically. Troubleshooting becomes easier. SCOM stops being that noisy tool and becomes a trusted operations platform. That's the difference architecture makes. If you remember just one thing from this video, remember this. SCOM is not just software. It's a system that must be designed like production infrastructure. Get the architecture right, and SCOM will work for you for years. Drop a comment and tell me which part of SCOM architecture was confusing before today. Let's clear it together.